My name is Brittany, and I'm a solutions architect at AWS. And as an SA, my role is not only to help customers understand our 200 plus cloud services, but really how to functionally combine those services to build applications and workloads that deliver real business value. Because of that, I spend a lot of time working backwards with customers to help them understand when to use which AWS service. For example, if they're trying to decide on a database platform, we first look at the type of data they're looking to store, any technical requirements for RPO and RTO, and any business requirements for total cost of the system and how they plan to consume the data. One of the most frequent topics that I find myself discussing with customers is data and analytics. Data has value, and increasingly, the ability to effectively use your data is becoming a key differentiator for companies of all sizes. If you want to start gaining real-time IoT insights on your equipment operating in the field, you need a strong data ingestion architecture and data storage design. If you want to start automating manual tasks and introducing things like machine learning and advanced analytics into existing processes, you need to know exactly what data you have and make sure that it's cleansed and formatted appropriately for each individual use case. And while the cloud can help unlock a lot of innovation in the analytics space, it also introduces new complexities. There are over 20 AWS native services in the data and analytics space alone, and they can be combined any number of ways depending on what you're trying to achieve. Not to mention the fact that you still have the ability to run the existing tools and applications that you're already familiar with, just deployed on the cloud. My goal for this series in general is to take those concepts that my customers find complex and ambiguous and simplify them. Specifically with data and analytics, for this video, I want to start at square one and talk about the concept of the modern data architecture and how we go about designing it on the AWS cloud. So with that, let's get into it. Traditionally, in data and analytics, we've used a data warehouse. In this model, we typically extract data from the source system, which are typically line of business databases, ERP systems, and other mainly relational data sources. Then we transform that data into a predefined schema, and then run reports and BI visualizations on top of the data. Because this warehouse approach has typically ingested structured relational datasets, it can be quite a challenge when you begin accommodating use cases that require semi-structured or unstructured data, like message payloads coming from IoT sensors, clickstream data from websites, and feeds from social media. Oftentimes, we need to create a completely separate system for housing these new data types, and that's how we end up with multiple data warehouse silos. In practice, maintaining multiple warehouses is an approach that requires significant CapEx, as well as high operational costs, and it's an approach that's only suitable for terabyte to petabyte scale scenarios. Now, that isn't to say that data warehouses don't have their place on the cloud. They absolutely do. And we'll come back to that point in just a minute. But one of the most common evolutions in data architecture that we see our customers take on is incorporating a data lake into their design. Data lakes are the next evolution of the analytics platform, building on the idea of a data warehouse, but still not a one-size-fits-all solution. With a data lake, your data is stored all in one place, and you have the ability to query it in place. Data lakes also have the capability to store structured data, semi-structured data, and unstructured data all in the same central repository. With data lakes, we typically land data in its raw format, then transform the data after it's loaded, which significantly reduces the effort and complexity of loading the data. We call this approach schema on read as opposed to schema on write, which you would see in a traditional data warehouse. A pain point we frequently hear from customers that rely heavily on data warehouses is that the process of bringing new data into the warehouse takes weeks to months, and you need to first define the target schema, then extract and transform the data to the target before you can even begin to gain insights from the data itself. With the schema on read approach, you can land your data in that central repository with as little friction as possible and start to gain insights almost immediately. From there, you can transform and cleanse as required to fit your needs. This approach enables you to leverage a wide variety of analytical engines, each with their own dedicated compute resources, executing against the data stored in your central data lake. Decoupling storage from compute not only frees up our choice of analytics tools, it also lowers overall costs, because compute resources are typically where the majority of your money is being allocated. Pure data storage is cheap. On AWS, the cost of storing data in Amazon S3, which is our object storage service most commonly used for data lakes, is anywhere from 2 cents per gigabyte all the way down to as little as less than a tenth of a cent per gigabyte of data. So this approach of separating storage from compute allows you to scale your platform to exabytes of data without racking up astronomical costs. However, a data lake does not solve all your problems and can itself become a data silo. If you move from dumping all of your data into a data warehouse to now dumping all of your data into a data lake, maybe you reduce storage costs, but you haven't actually delivered any new insights or additional value to the business. The reality is that services purpose-built for specific use cases will often outperform more generalized services, such as a data lake. Which brings us to the modern data architecture. With a modern data architecture, you enable ingestion from a variety of data sources, including operational databases, file shares, and IoT devices. You also empower your teams to leverage different analytics tools and machine learning capabilities by choosing their preferred technology for that specific scenario. Your data lake is one piece of the architecture, but equally important are those other services like a data warehouse, operational databases, and AI/ML services, all coming together to enable your end users, applications, and devices. And that idea is so important. The purpose of your data architecture is to support the business with data-driven use cases that add real business value. If you start defining your data architecture and don't know who your end users are or how they plan to use the data, you need to pause, take a step back, and think holistically. Some use cases, like reports and dashboard visualizations, are best served by moving that data into a highly performant data warehouse. Some use cases, like self-service analytics, are best served with a central data lake. Some scenarios require the use of machine learning services, and some require integration with your line of business databases. The real reason those prior evolutions of data architectures failed is because they tried to be a one-size-fits-all solution, instead of choosing the right tools for a specific end-user scenario. At a very high level, this is how the modern data architecture translates to AWS services. It can be defined with 5 key pillars. The first is data at any scale. You can use Amazon S3 to build exabyte-scale data lakes on the cloud. You can also integrate purpose-built data stores like DynamoDB, which is a serverless key-value database, and Amazon Aurora, which is our proprietary database compatible with Postgres and MySQL. Enabling data storage at scale doesn't mean choosing one tool to house all of your data indefinitely. The second pillar is best price performance. The idea is that by using the ideal tool for a specific use case, you achieve the best price to performance ratio. For example, you could store the majority of your data in an S3-based data lake and just move the relevant data sets into your data warehouse when you need it for reports. The third pillar is seamless data movement. We can move data seamlessly between services by using AWS Glue, a serverless Spark-based data integration platform. And we can also leverage other AWS native services designed specifically for the ingestion and movement of different types of data. Number 4, United Data Governance. AWS Lake Formation is an abstraction service that sits on top of your S3-based data lake to provide centralized governance and enforce fine-grained access control across your data stores. And finally, AI/ML integration. Like I said, most likely we will all continue to support use cases that require reports and dashboards. However, some of the most impactful data-driven use cases being explored today to solve new business challenges rely on the use of AI/ML. On AWS, the idea of seamless data movement and data governance doesn't just apply to the data stores, but also to the integration of your traditional analytics services and any machine learning services as well. So I know going from that last image to this one might be a shock to the system. This diagram is overflowing with icons, but we can apply the same 5 pillars of the modern data architecture and really simplify what we're looking at here. So the first pillar, data at any scale. We see that with our scalable data lake built on Amazon S3. Number 2, best price performance. We have our suite of purpose-built analytics services on the right, as well as our unique data ingestion services depending on your data profile on the left. I mentioned the cost-saving mechanism of decoupling storage from compute earlier. On the right, under purpose-built analytics, we have Amazon Redshift, which is our cloud-native, highly performant data warehouse service. We also have Amazon OpenSearch, a fully managed OpenSearch platform that runs on AWS, and Amazon EMR, a fully managed Hadoop cluster service available on the cloud, along with many others. The reason that these services are clustered together on the right is that we don't recommend storing large amounts of data long-term in any of these services. Instead, we recommend moving data from the central data lake into a specific analytics service only when it's needed for a particular use case. Number 3, seamless data movement with AWS Glue to transform and load data into our various analytics services. In a separate video, I'll lay out the different user interfaces for Glue, such as Glue Data Brew, which is Glue's no-code interface for visually authoring ETL jobs. Number 4, unified governance ensured through the use of lake formation on top of your data. And finally, AI/ML integration with both Amazon SageMaker, a fully managed machine learning platform running on AWS that data scientists can leverage, and also higher-level AI services for business users that want to leverage machine learning but don't have the data science expertise. So there you have it. If nothing else, I hope you walk away from this video understanding that the modern data architecture is actually a strategy, and the way it gets implemented is going to be different depending on your unique business and technical requirements. The core pillars are there to guide you and help you think holistically, storing data at scale, integrating purpose-built analytics and AI/ML services, and applying centralized governance. And from there, the specific building blocks you choose will be based on your data profile, your end users, and how they plan to use that data. If you enjoyed this video, check back soon for similar discussions on when to use which AWS service for data storage, data ingestion, and data consumption, and let me know what other cloud computing topics you need simplified.